is Thomas Speck. I have a chair for functional morphology and biomimetics at the German University of Freiburg, and I'm the director of the Botanic Garden.
I'm Günter Reiter. I'm in the physics department of the same university. We are working on polymers and also in an interdisciplinary context.
For me, it's just fascinating what evolution has produced. So we want really to learn from nature, and bioinspiration is a great chance to do that. And you have to start with materials, and then you come to material systems, and then you at the end come perhaps to the entire solution.
Yeah, and if you're looking at the same problems from a physics point of view, then you're realizing that in physics you can still learn a lot from nature, in particular when it comes to situations where energy is invested. Like in nature, you're all eating in order to survive. And for that, physics has not yet developed the right tools to describe these kind of situations out of equilibrium.
Yeah, we have, for example, looked at different fruits and tree barks for energy dissipation. So a lot of fruits survive drops from relatively high levels from the trees without splitting open. So we looked at the pomelo and we developed new kind of foams which are used now in helmets, protecting helmets and other protection gears. And what we do for a couple of years, we look at plant movements and we produce bio-inspired facade shading systems for a kind of new, more aesthetic and especially more resilient architecture.
I think it's even more than just natural, it's a requirement. Because if you want to understand whatever you see around you, then you have to understand how nature is doing it. And learning from nature is helping you to develop then the concepts which the biologists will eventually use. So I think it's not something which is forced, but something which is a must.
And I think there is another aspect which is often overlooked. You think there is a technical world, there's a biological world, but they share the same physical chemical environment. So if you drop, for example, fruit somewhere from a tree, it follows the same laws of physics than if you drop a hammer from a scaffold. There is a lot of basic similarities, you have just to grab them and to translate them. And this is what I think both of us are absolutely fascinated about it.